Hi students, good morning. Welcome to our video classes. We know that the state of matter can be changed by changing the temperature. For example, solids on heating changes into liquids, and further heating the liquids changes into gases. That means there is effect of temperature on the state of matter. And already we have learned about boiling point, melting point. That means when we heat a solid substance, it changes into liquid. That means it melts. This process of changing the solid into liquid is called as melting. And we heat a liquid, the liquid changes into gas, it is called as boiling. During melting or boiling of any substance, there is no change in temperature even we supply heat. That means the temperature remains constant during the change of the state of matter. This constant temperature at which a solid converts into liquid, that is called its melting point, and the constant temperature at which a liquid changes into gas, that is called as boiling point. The water boils at 100 degrees Celsius. That means the temperature remains constant at 100 degrees Celsius when this water changes into steam. This 100 degrees Celsius is constant. This constant temperature is called as the boiling point of water. And is the boiling point of all substances is same? No, it is different for different substances. Why it is different for different substances? The attraction between the particles of all liquids is not same. That's why the boiling point is also not same. That's why this boiling point is a measure of the attraction between the particles of these liquids, and in the same manner the melting point of a substance is a measure for the attraction between the solid particles. And this boiling point depends on pressure also. At normal atmospheric pressure, water boils at 100 degrees Celsius. Is the water boils at 100 degrees Celsius at every pressure? No. When the pressure changes, then automatically the boiling point also changes. How? If the pressure increases, the boiling point also increases. In the case of melting point, if pressure increases, melting point decreases. But in the case of boiling point, if pressure increases, the boiling point also increases. Observe, when we cook food in a pressure cooker, it cooks fastly. How it is happened? That means in the pressure cooker, the steam which is produced, that is trapped. Whenever the pressure is trapped, the pressure inside the pressure cooker increases. That is higher than the pressure in a normal vessel. Okay, that's why when the pressure increases, the boiling point of water in the pressure cooker also increases to 120 degrees Celsius. In a normal vessel, the boiling point is in normal vessel means at atmospheric pressure, the boiling point is 100 degrees Celsius. But in a pressure cooker, pressure is high, that's why the boiling point is also high, that is 120 degrees Celsius. Okay, that's why the food cooks fastly in a pressure cooker. Okay, in higher altitudes, the atmospheric pressure is low, that's why it is better to use a pressure cooker to cook the food materials. Okay, next about other process. That means this when a substance is heated, the solid is changed into liquid and liquid is changed into gases. Now we will learn about the reverse process of this melting and boiling. What are the reverse process? Okay, when we heat substances, what is happening? The particles of that matter gains energy and the state changes from lower phase to higher phase. That means whenever the particles absorbs heat, the particles solid matter is changed into liquid matter is changed into gaseous matter. Then if the particles are cooled, that means if the matter is cooled, what would happen? The particles lose energy. When particles gain energy, they move further. And in the same manner, when the particles lose energy, what is happened? They come closer. Okay, then that are the condensation and freezing. This condensation is the reverse process for boiling or evaporation. In boiling, actually what is happened? The liquid substance is changed into gaseous substance. Okay, that means on absorbing heat, But if the particles lost energy, then this gaseous matter is converted into liquid matter. Simply it is condensation. Okay, it is in our daily life experience we observed when a when a water bottle is taken out from the refrigerator and it is placed on a table, we observe water droplets. How these water droplets are formed? Simply that is due to condensation of water vapor present in the atmosphere. Okay, around the water vapor, what is there? Air. The air contains water vapor particles. That means water in gaseous state. When these particles of air moves, they contact with the cooling water bottle. Whenever these water vapor particles in the air contact with the bottle, cooling bottle, then these particles, the water vapor particles, lose energy. That means heat is transferred from water vapor particles to bottle. Then that means the water vapor particles lost energy. Whenever they lost energy, what is happened? These particles come closer and closer, and they gets condensed. Means water vapor is changed into water. Like that it is happened. And during some winter nights, okay, winter nights means the temperature is very low, we observed water droplets on window panes, bike seat covers, petals of the flowers, leaves. How these water droplets are formed? That is also due to condensation of water vapor. Due to condensation of water vapor present in the atmosphere. Okay, during that winter nights, the temperature is very low. That's why all these things which are present outside, that gets cooled. That means the temperature decreases. Then the water vapor particles contact with these things, that petals of flowers or leaves or window panes or bike seat covers. Whenever they are contact, then these water vapor particles lose energy. Whenever they lose energy, again that higher phase, say water vapor, is converted into lower phase, that is water. Simply that condensation takes place. This formation of snow, mist, that means fog, all these are due to condensation. Okay, that means during some winter nights, okay, while we are traveling in early hours, okay, that there is a restriction for visibility. That is due to fog. How the fog is formed? That means in air, dust particles are also there. The dust particles, due to lower temperature, that are cooled, and the water vapor particles are condensed on these dust particles, then they float along with the air particles, which restricts the visibility. The thick mist which restricts the visibility, that is called as fog. That is also due to condensation. Like that we observe this condensation, which is the reverse process for evaporation or boiling. Next, freezing. Again, this freezing is also done due to cooling. It is also reverse process for melting or fusion. In the case of melting or fusion, what is happened? A solid substance converts into liquid, okay, when energy is supplied. But if the liquid particles lose energy, then what is happened? That are condensed and converts into liquid. Okay, in refrigerator, in a that means in freezing region, if you place water, what happens? That converts into ice. What is happened? That means when water is placed, that is cooled. That means its temperature decreases. It lost energy. The water particles lost energy. Whenever that water particles lost energy, that come closer and changed into solid. This phenomenon of changing a liquid into solid, simply that is called as freezing. It is observed in our daily life also. In winter season, coconut oil, okay, or some other oils that are changed into solid state. How this is happened? That is due to freezing. That means that higher phase liquid is converted into lower phase, that is called as a solid. That's why it is freezing. Simply this freezing means solidification, while liquid is converted into solid on losing energy in the form of heat. Okay, then we have learnt about melting point. That means at which constant temperature the solid converts into liquid, that is its melting point. This melting point of a solid is same as the freezing point of a liquid. For example, if the melting point of ice is 0 degrees Celsius, again the freezing point of water is also 0 degrees Celsius. Why? At that 0 degrees Celsius, we observe the equilibrium between ice and water, that means solid particles and liquid particles. Okay, these are the phase changes. when the temperature of a substance changes. Okay, that means on heating, lower phase is converted into higher phase. On cooling, higher phase is converted into lower phase. That means heating or cooling means what is changed? Temperature is changed. That means this is the effect of temperature on the state of matter. Again, the pressure also affects the state of matter. How this pressure affects the state of matter, later we will learn. Okay, next, in the case of melting and boiling, we observed clearly during the melting of any substance or boiling of any substance, the temperature remains same. That means there is no rise in temperature even we supply heat. Where does this energy go? That means during first the temperature in our previous activity, the first whenever we heat ice cubes, the temperature rises from -3 to -2, -1, 0, and it remains constant at 0 even we supply heat. That means where does this heat energy go? This heat energy which is supplied at that stage is used for somewhat. That's why there is no rise in the temperature of the substance. How this is utilized? Okay, that is in the form of latent heat. That means latent means here hidden. Okay, that hidden means the heat is not observed. Whenever the heat is observed, that means that effect is, if there is a rise in reading of the thermometer, then the effect is clearly observed. But during melting of ice, say at 0 degrees Celsius, or during boiling of water at 100 degrees Celsius, even we supply heat, there is no rise in temperature. Okay, why? That means this heat is used for somewhat. That means on heating a substance or cooling a substance, what is happened actually? When energy is supplied in the form of heat, that heat energy is readily absorbed by the particles of matter, and the particles of matter vibrate vigorously. Whenever they vibrate vigorously, and a stage is reached. At that stage, the energy which is supplied breaks the attraction between the particles of matter. They simply, whenever the attraction is broken, they move apart. That means solid is converted into liquid, or liquid is converted into gas. Like that it is happened. That means the heat energy which is supplied at that stage during melting or boiling is used to break the attraction. That's why during melting or boiling there is no rise in temperature. At the same case, okay, there is the rise in the reading of the thermometer is not observed. That means the heat is hidden. That hidden heat is called as latent heat. Okay, observe this curve, observe this graph which shows the temperature and heat. In the first case, simply, that means on horizontal axis at -25 degrees Celsius, what is there? Ice cubes. On heating these ice cubes, first what we observe, the temperature increases from -25 degrees Celsius to 0 degrees Celsius. And whenever the temperature reaches to 0 degrees Celsius, is it increases continuously? No, it remains constant at 0 degree Celsius. It remains constant at 0 degrees Celsius, and at the same time ice is changed into water. At this stage, even we supply heat, there is no rise in temperature until all the ice is converted into water. That's why at this 0 degrees Celsius, what is the melting point of ice? Without rise in its temperature, okay, without rise in its temperature, the heat energy which is supplied, okay, the heat energy which is supplied is used to change the state of matter without rise in its temperature. This heat energy which is supplied to the substance to change the state of matter from one phase to another phase without rising in its temperature, simply that is called as latent heat. Okay, already I told you what is meant by latent. Latent means hidden. Why? During the conversion of this phase, that means during the conversion of the state from one phase to another phase, there is no rise in temperature. That means the temperature remains constant. That means during melting, the temperature remains constant at its melting point, and during boiling, the temperature remains constant at its boiling point. That's why without rise in its temperature, okay, the phase is changed, the state is changed from one phase to another phase by the heat which is by utilizing the heat which is supplied. That's why that heat is called as latent heat. Again, this latent heat is of two types. Why? In two cases that phase is changed. Okay, solid to liquid and liquid to gas. When the matter is changed from solid to liquid without rising its temperature, that means at its melting point, the heat utilized is called as latent heat of fusion. Then what is about latent heat of vaporization? When the matter is changed from liquid phase to gaseous phase at its boiling point, means the temperature is constant at its boiling point, that heat is utilized. Okay, that is called as latent heat of vaporization. That means simply, what is latent heat? The heat energy which is required to change the substance from one phase to another phase without rising its temperature. That means at constant temperature. Simply, that is latent heat. Okay, again this latent is of two types: latent heat of fusion and latent heat of vaporization. About this latent heat of fusion and latent heat of vaporization, we will learn in next classes. I hope that all you understood, okay, about this change of matter. That means solids on heating changes into liquids, liquids on heating changes into gases, and gases on cooling changes into liquids, liquids on cooling changes into solids. Okay, this first phase, solid to liquid, conversion of solid to liquid by heating, that is melting or fusion. Liquid to gas, that is vaporization or boiling. And gas to liquid, that is condensation. And liquid to solid, that is freezing. Okay, thank you.